Hi, we are from Group 9. My name is Alif.
My name is Amir.
My name is Asrina. The question that we get is to determine the natural response of an RL circuit with a parallel inductor. So I will explain the question A.
I will explain question B and C.
And I'm going to explain question D about energy.
Enjoy our video.
This circuit is called the RL circuit, which is have a parallel inductor L1 and L2. L1 is given that 5 Henry and L2 is 20 Henry. You can see that the current flow to L1 is I1, L2 is I2, and I3 is flow through the resistance of 10 ohm. So the first question is to find I1, I2, and I3 for t is greater than 0. So as we know that I0 for I1 is equal to negative 8 ampere and I0 for I2 is negative 4 because they have a opposite sign of this current. So I1 is 5 Henry and L2 is 20 Henry. So first we need to find the inductor equivalent of this inductor. So as we can see that the equation, and after the calculation we get the L equivalent is equal to 4 Henry. Okay, next to find the R equivalent. So we need to solve this equivalent, as we know that 15 ohm and 10 ohm is parallel and series to 4 ohm and parallel to this 40 ohm. So after the calculation we get the R equivalent will be 8 ohm. Okay, next we need to find the tau. Tau is equal to L over R, which is L is 4 ohm, L equivalent and R equivalent will be 8 ohm, and we get 0.5. So we know that the I total is 12. 8 plus 4 is equal to 12 ampere, which is equal to IT. So you know the IT is equal to I0 exponent negative t over tau. So after that we just include the value into the equation. The I0 is 12 and the tau is 0.5. We get the final answer is 12 exponent negative 2t. Okay, next is to find the I. To find the I, the equation is 1 over L integration of V d tau plus I0. So we know that from this equation we don't have any V, so we need to find it using this equation. Ohm's law, Vt is equal to IR. So the I we just get from this IT, and R we get from the R equivalent. After that we get the Vt is equal to 96 exponent negative 2t volt. Next we just find the I1, I2 and I3. I1 just include the value of 1 over L, which is the L1 is 5, and integration of 0 until t, because we don't know the exact value of t, 98 exponent negative 2t d tau minus 8, because the I0 of the L1 is 8, negative 8. That's why we minus 8. After the integration and the calculation, we will get the I1 is equal to 1.6 minus 9.6 exponent negative 2t ampere. Okay, next Next is to find the I2. I2 is equal to 1/20 because the L2 is 20 Henry. Integration of t to 0 to t 96 exponent negative 2t d tau minus 4 because the I0 for L2 is 4, negative 4. After the calculation, we will get the negative. The answer is negative 0.16 minus 2.4 exponent negative 2 ampere. Next, to find the I3. As we know that the I3 is flow through the resistor of 10 ohm. So to find it, we use this equation, Vt over R. After that, after we rewrite the circuit again, we know that current flow through the 4 resistor also same with the current flow through the I3 through the 10 ohm, which is I3. So I3 is equal to I4 ohm using the current divider rule. After that, you just include the value to the equation. I3 is equal to 15, the parallel resistor into this, over 25, 15 plus 10 times Vt over 10.
Okay, so for part C, this is the original diagram from the question, and for C is we need to calculate the initial energy stored in the parallel inductors, that is L1 and L2. So we use this formula, W equals to half Li square. This is the formula for energy in each inductor. So for L1, we just substitute 1/2. The inductance is 5 Henry and the current is negative 8 ampere because I1 is traveling the opposite direction with L1. The same thing goes with L2. W is half 20 Henry, negative 4 ampere because I2 is traveling the opposite direction with the inductor. For both inductors, we got 160 joules. And we total up L1 plus L2, 160 plus 160 equals to 320 joules. For part D, we need to determine how much energy is stored in the inductors as t approaches infinity. So from A, we have learned that the formula for I1 is 1.6 minus 9.6 exponential negative 2ta. For I2 is negative 1.6 minus 2.4 exponential negative 2ta. As t approaches infinite, we'll just substitute t as infinite in each of these formula, and we get I1 equals to 1.6 as exponential negative 2t to infinite, we get 0. So for I1 we got 1.6 and I2 we got negative 1.6, and we use this formula, W equals to half Li square, but instead of we substitute I as 8 ampere or 4 ampere, we substitute as I1 equals 1.6 and I2 is negative 1.6, and the total for both inductors is 32 joules.
So now I want to explain about question D. Show that the total energy delivered to the resistor equal the difference between the result. So we need to find the total energy. First, we need to know the power. So for the power equation, we have for the normal equation P is equal to IV, and also we can get I square over R and V square over R. It depends on you what you gonna use. So for find the total energy, then we need to integrate the power with this equation. The limit is 0 to infinity because we know that when t is 0, and t is so when t is greater than 0, then the inductor will supply the energy to resistor. So it's going to 0 to infinite. So from this, we need to find Pt first. P the velocity. So this is equation that P the velocity is equal to I various time times with V voltage. So for this, we know that we can get from another equation that above, that I the velocity is 12 exponential e to t, V the velocity is equal to 96 exponential e to t, and R is going to use the equivalent of resistor that we get 8. So we product the I and V, can get 1152 exponential E40 watts for the power. So now we can use the integrate part. Then we use the limit to 0 to infinity, and we integrate the part of power. And you use the integrate, like you can get this result. That is 288 joule. So from here, from B equation, you get the initial result that 320 joule. And C, when t is approached to infinity, that means the end of the time, you can get 32 joule. So it proves that total energy stored in inductors is, we plus the 288 and 32 joule, and we can get the total energy that when is t equal to 0. So that's all for D.